Okay, Khalid, you can try to join. Okay, I have to remove it regarding to technical issue here. Okay, so I give you some a very short briefing for the lab. So in the YouTube links, I will upload the two links. Firstly, regarding to the session, to the course topics that you have learned just now, and secondly about the lab briefing lah. Okay. This morning, I have upload. I have upload. Sorry, in the Google Classroom. I have uploaded this document in the Google Classroom, Laboratory Matlab Simulink Control System Engineering 2. So this is some guidance for you. You can refer to do the Matlab Simulink lah. Okay. So this is tools Matlab Simulink toolbox, and then the file Matlab Simulink figure 1 until 5 show the steps how to open and operate the Matlab Simulink. So just follow figure 1. Open Simulink by click the Simulink icon here. Figure 2, open a new model in Simulink by click the new model icon here. This is I just want to show you first, then I will demonstrate. And after that, insert the Simulink parameter by click the library browser icon. This is the library browser icon here. And after that, search the required parameter in library browser by typing in search box. This is the search box, you just by typing them. Okay, and then after that, drag the required parameter into the new model workspace. So the common parameters that we will use for the lab, this one in this table, refer to the table 1.0. We have as the input, you can put step. You just search step in this search box. Okay. And then after that, this is the symbol that you obtain from the Simulink. And then for the output, you just need to type scope, and this is the icon. And then for the integrator, this one, and then for the derivative, you just need to type derivative, and this is the symbol icon. And then for the transfer function, you put transfer FCM. Then you obtain this one for the gain and then for the sum. Okay, so this is the common parameters that you need to use in order to do your lab one. So please refer to this document. So now I would like to explain to you directly using the Matlab software. Okay. Okay, now let me see the other screen. All right. Okay, this is the 2021 Matlab. Okay, so firstly you double click the Matlab icon, and then you will directly to this interface. And after that, if you can see here, there is a Simulink. Just click the Simulink. Click the Simulink. You will directly to this one. Okay. And then after that, you just click blank model, create model, create model. It takes time. Still loading. Let me close a few things here. Why this is takes so long? Normally it's not. Escape here. Stop and edit now. Okay. So we need to click the Simulink again. Okay, I restart the procedure. Okay, now I click the Simulink. Sorry, I open again the Matlab. Hmm. Okay. Alright, you open the Matlab and click again the Simulink. And after that, you click the blank model or create model. If this process taking quite long time, I think I will record a video for you to, yep, to explain to you how to do this. We wait until just a few seconds. Let's say if this taking a few times, so I will record a video and I will upload in the Google Classroom. All right. Okay, finally. All right. After you click the create model, yeah. Okay. Before you proceed with your simulation analysis, firstly you must have your state space equation lah. Let's say this is the first your state space. X1 dot x1 dot t equal to x2t. Example lah. I will make it bigger. And then you have the second, this is second order system, x2 dot t equal to negative 2x1t minus 3x2t plus with 2ut. Okay. So this is your state space. Okay. And after that, your output, this is second order. Your output equal to x1t only. Okay, so this is your state space. Alright. After you know your state space, now you can run your state space using the Matlab Simulink. Okay, so you can see your order of the system is second order. Okay, so what you need to have is you need to have two integrator. Using the new Matlab Simulink, you just can double click the page, the empty page, and then you find integrator. The integrator, you just need to refer to the table that document that I uploaded in the Google Classroom lah. Because there are two second order system, you need to have two integrators. Okay, one, two. Okay, two integrators. This is second order system. Second order system, two integrators. Third order system, three integrators. And then after that, you just label the lowest of the x here is x1. X1t, is it? And then after that, you have x2t, you have x1 dot t, you have x2 dot t. So you go the lowest part is you have x1. We go to 72. A. 48. Okay. Here we name as x1t. Here we name as the x2t. I will explain to you why this is happen. X1 dot t. Okay. Here I name as a x2t. And here become x2 dot t. So you can see the relationship. If you have x1t, there become x1 dot t, x2t, x2 dot t. Since you have two second order of the system, you have two integrators, and after that you just name according to the states from lowest to the highest. Why? The integrator 1 over s actually refer to the integrator. 1 over s, you can see that the words here integrator. If you have something that dx1t over dt, if you integrate it, it become x1t. Okay, x1 dot t here, you integrate it, become x1t. If you have x2 dot t here, if you integrate it and become x2t. Okay, so that's why become that. So that's why this is s1 dot t. You integrate, you do the integration or kamiran terhadap x1 dot t, or you do the integration on x1 dot t and become x1t lah here, and similar to the x dot t. Okay, and then after that, this is the first basic that you must have. Okay, after that you just proceed with the equation. You see that x1 dot t equal to x2t. So you can see that x1 dot t equal to x2 dot t. So you click or you connect the wire lah, because according to the state space, s1 dot t equal to x2 t. So now you already connect it. So that's why become x2 t also equal to x1 dot t. Done. Okay, and then go to the second part. x2 dot t. This is the x2 dot t area. Okay, input equal to negative 2x1t minus 3x2t plus 2ut. Okay, so what you need to do, you need to find, double click and search gain. I will make it bigger. Okay, bigger. How many gain do you have? Firstly, you have the first gain for the x1, and then you have the second gain for the x2, and then you have the third gain for the ut. So you need have to three gains. Gain number one, gain number two, and gain number three. Okay. Gain number one equal to negative 2. Double click and you just put it negative 2. Okay. Gain number 2, negative 3. Double click and type negative 3. Gain number 4 is 2. Sorry, gain number 1, negative 2. Gain number 2, negative 3. Gain number 4 is positive 2. Okay. So now we can see that the first gain, negative 2, must multiply with the x1. So this is your location of x1 must multiply with the negative 2 gain. So you just connect it. And then the gain number 2 equal to negative 3, the value, must multiply with the x2. So this is the location of x2. Okay, this is the location of the x2. So you just connect them together. Done. And then finally, the last gain must multiply with the ut. As I mentioned earlier, ut equal to input. Okay, according to the table that I provide in the Google Classroom, the input normally you can double click, you search step. This means the step input. Okay, so this is the step input. Okay, and then you just connect input multiply with the 2. You can see input multiply with 2, input multiply with 2. Okay, however, the combination of the x2 dot must be combine everything here. Negative 2x1 plus negative 3x2 plus with positivity. So you can see that this is negative 2x1, negative 3x2, and ut multiplied with 2. However, it's not, they are not connected each other yet to combine to give you x2 dot. So what you need to do, you just double click, you put sum. So this is sum. Control Z. I need to make it bigger. So this is sum. However, for the sum, you need to move it a little bit. Yeah, you can move the position. Okay. According to the sum, when you double click the sum, there are only two, positive 1 and 2. However, you need to sum 1, 2, 3 items. Okay. However, in this case, only 2. So what you need to do, you just double click and put another sum plus sign here. So now there are 3 plus signs when you double click the sum. So now you already have 1, 2, 3. You have 3. So what you need to do, you just connect them together. 1, 2, 3. And then you connect to the x2 dots. Now we check again the equation. Is it correct or not? x1 dot t equal to x2 t regarding our state space equation. So now x1 dot t equal to x2 t. Correct. Done. x2 dot t equal to negative 2x1 t minus 3x2 t plus 2 ut. You see that this is x2 dot t equal to negative 21x1 t, correct, plus with negative 3x2 T, correct, and plus with 2 UT. UT multiplied to 2 UT, correct. And then we did not finish yet the output, YT. YT equal to X1T. As you can refer to the document that I've uploaded in the Google Classroom, output we normally use scope. You just search scope, and this is the output. And then we know that the output equal to X1T here. So you just find this is your S1T here, and then you need to connect to the output. Done. This is your Simulink. And then after that, we need to run lah. We need to check, is it the system stable, unstable? Is it the system have error or did not have any error, something like that. So we can see in the output scope. So what you need to do, you have this run button. You just click run. Run. Okay. And then you just double click the scope. Okay. Double click the scope and see the results. All right. So based on your observation, I would like to ask, alamak. I want to ask Anis Amira, the system stable or unstable, Anis Amira?
The system is stable.
Yes, that's correct. Stable, because you can see that this is only 10 seconds. However, you cannot see until finite time. So how you want to make it? You can change the stop time to make it more longer. Before this, I said about 10 seconds. I make it to 40 seconds. So I just run, okay, and see that you can see the running time here more longer, up to 40 seconds lah. So you can see that in the until finite time, the system is stable because the system is converged to one final value. Okay, and then after that, I need to change this one because step time we keep it 0. Okay, and after that, let's see what's happened if the system is unstable. I try to change one of the post location. I make it about 2. Okay, let's see what's happened. Run. This is the system unstable. Let's see. This is the form of the unstable system because I changed the post location. So you can see that the output or the system is unstable. So it means that why you learn about the converting the system, okay, to state space, because you also can and do the analysis using the state space, but and then see what is the output of the system lah. Okay, in control 1, you learn to convert from system to transfer function and observe the output. However, the second option, you also can use state space by converting system to state space and run to see the simulation output. So I change again to -2 with the post on the left hand side of the explain. So the system will become stable again. I make it about 20 seconds lah. But it's quite long time. Okay, so it becomes stable again. Okay, because I change back the location, post location. All right. So and then after that, in this case, during the lab, you need to analysis. You need to determine either the system stable or unstable. Firstly, you need to look at what is the error for the system regarding to the input. Okay, if you give this kind of the input, how many is the error of the system? So this everything you need to do the analysis lah during the lab. And after that, you need to give some suggestion lah how you want to improve the performance of the system. Let's say the system have error. So what is the performance? What you need to do in order to improve the performance to make sure the system have 0 error. something like that. And then let's say you can see that the time response for this quite slow. Maybe you can try to make it more faster. So you can see that you only achieve the final value on 8 seconds. Maybe you can try to make it more faster, about 2 seconds. Maybe. So this is the kind of the analysis you need to do during the lab session. All right. Okay, so I think that's all for the class today. So I will share this video in the YouTube link, and then you can, and also I can you try to run it by yourself lah, using the Matlab Simulink. So this one I will not save this Simulink, so you can try by yourself to see the answer and compare the answer with the video. Okay, and then after that, let's say if you didn't have anything, so I will share the attendance link in the Google Classroom, in the chat box. Okay, save this one. So please find the attendance link in the chat box. And then as usual, wait, did I save lah? As usual, I will wait another 5 minutes for you to have Q&A with you. If you don't have any question, you can leave the meeting. Okay, thank you so much for your response and attention throughout the class. Okay, Assalamualaikum and have a good day to you. And keep safe.
Thank you, Tata.